This conference will now be recorded.
Yeah, so yesterday we learned about the basic data types used in Python and had a basic introduction about Python and what basic functionalities we have there present there. Today we'll be covering topics such as conditions and iterations and functions. So before going on to these topics, there were some of the things which I want to tell you about, like which Python version I'm using. So I'm using Python 3.6.5 version, and this is a Jupyter notebook. So this is an open source tool for IDE for programming in Python, and you can get it from this link. There's just two basic steps which you need to do, and a simple Jupyter notebook command to run it. So this you can run from your command prompt in Windows or your terminal from your Linux or MacBooks. So here I have a Windows PowerShell in which my Jupyter notebook is running, and this is the site for downloading Python version. So the latest Python version is 3.7. I am currently using 3.6.5. There is another IDE. If you are having troubles installing Jupyter, you can make use of PyCharm, but you can only use the community version because the other versions are licensed then. So which IDE to use is basically upon you, that which versions you want to make use of. So for specific, okay, I have a question. PyCharm is an IDE similar to Jupyter. So you have to uh, install Python first. So this is a site for Python, and only after that you can code in Python. So just like in for coding in Java, you need a JDK install. Similarly, you need the Python installed for your programming in Python. The PyCharm and Jupyter are just IDEs which will make your coding easier. I mean, it will provide you interface for coding. So that's just about Jupyter and PyCharm. So let's head on to our topic. Yeah, Arun, it's similar to what you have in R, that R Studio is your ID and you have a base R installed before that. So it's similar to that. So now first we'll discuss about conditional statements. So in Python we have the if, elif and else. Uh, what do we mean by that is if I have a value, suppose I have here a defined as true, and then I can have a condition like I want to perform actions based upon what the value of certain variable is. So here I have a defined as true. So in the conditions, if a is equals to true, then it would print, or it would do certain actions. So here I am doing an action. I'm just printing a string here. Otherwise, if the value is not the one which I want, then I can have another action performed accordingly. So here, since the value is true here, that's why it went to the if clause, and this branch of the conditional statement was executed. If the condition is not satisfied, then it will go to the else branch and it will just perform the action defined in the else branch. Now we have the elif also, so you can have more than one conditions, right? So suppose you have a value, integer value, and you want to check whether it is a 0 or a 1. Basically, is it a binary value or anything according to your use case, whether the value we can check for range of values, whether it is greater than equal to 0, something like that. So accordingly, it will execute the branch which will satisfy for that particular value in it. So here we have this uh, range of comparisons. So accordingly, we got the answer here that because 10 falls between 0 to 20, so the first if branch was executed. Now we also have nested ifs, or we can say nested conditional statements. So by that I mean that I can remove this, and I'll just remove all of this, and I'll put another if clause inside this, and I'll write that whether the value is less than 20 or not. If the value is less than 20, then I'll have an action. So I'll have the action that the value is between 0 to 20. And I can have another else here, and I can print another action saying that the value is greater than 20. And similarly, I can have an outer else as well, which would just define that the value is a negative integer. So something like that. So accordingly, it would print, it would go inside the nested if. We can have many layers, but for illustration, I'm just using one if inside. So this is how the nested if works. So in Python, we have only if else for conditional statements. And if some of you have a background of C or Java, then you might have used another conditional statement called as the switch case. So that is not present in Python, but we can have a workaround for that, and that I'll discuss later on in the session. So till now, if you have any doubts regarding conditional statements, you can write in the chat box. Okay, then I'll just carry on to the next topic. So the next topic is iterations. So in Python, two types of iterations are supported. One is the for loop and the second is your while loops. So there are reasons for which we have these types of looping. So for instance, I have a list as we had discussed yesterday. I have certain list of elements. Now, if I want to access each element of that list, then I need something to iterate through it, right? I need a looping mechanism. So for loop is one such mechanism through which we can do, and it would just access each element of the list, and then we can perform any action. So for here, we are just printing the value present in the list, and we got all the elements accessed here. We can even print a change in those uh, actions and have a different action as well. So this is about for loop. Now suppose we have a dictionary. So I have a dictionary which holds some values like this. Yeah. So I have this dictionary, and now I want to iterate through this. So I can make use of the for loop here as well. As I told you yesterday in yesterday's class that dictionaries has some functions called as this dictionary.keys dict.keys. So what it would get is that it would get each each key present in the dictionary. So that is what val will print here. So it printed all of the keys present here. Now suppose I also want to have the values which are present there. So one way would be to use this. Since I am able to access the keys, I can get the values as well, right? So this way I can get the key value pairs, or we can make use of another function. Badal is asking that whether val is default variable. No, you can change anything. You can have it as I. You just need to make the changes correspondingly to everywhere. So here I took I. It's just that I was accessing values in the list, so I took the variable as well, just for understanding purposes. You can have it as I, you can take any name, any variable name. So that's regarding the variable name you choose for in for loops. Now there is another function which is called as items. So in items you get both the key and the value from the dictionary. So you don't need to access it from the dictionary using key, because you'll be getting it from the function itself. So here you did a mapping to it. So this is called as your, uh, suppose I have this as the value. So this is the mapping which I did. So if I print a comma b, so one was corresponding to a and two was corresponding to b. So this is exactly what I did here, and this is actually called as unpacking. So it works for your tuples as well. So the value got mapped, and since dictionary.items returns a list of tuples, so if I print this, so see, you can see that it is a list of tuples here, and so each tuple was unpacked here, and then I was able to access the elements. So this is how I can iterate through the dictionary. Also, there is another function which is called as values. So if I just want the values out of the dictionaries, I can just iterate through the values present. So this is all about the for loops. Now, yes, there's one more thing which we can make use of, which can be helpful when we are making use of, when we know the length of a list or any iterable object. So suppose we have something like list one and we want to iterate through it. So while printing this, we only got the indices present in the list. Now, if you want to access the values of the list, I can make use of the index which I'm accessing through the range function, and then I can have the access to the values as well. So this is helpful while when I know or I have access to the length of the list, and for loops are really great while doing that. I can also make changes to how much length I want to access. So I can give a number here. So it accessed from the second index to the last index. So 2 here means index and not the position. So that's why we got the answer as, let me just change the values, otherwise it would be confusing. Yeah. So 2 is actually an index. So index 2 means third position. So that's why we have the elements accessed from 30, 40, and 50. So this is all about for loops. If you have any questions, you can ask. Otherwise, I'll move on to while loops. Okay, so let's move on to while loops then. In while loops, you can make use of conditions, and then you can iterate through them. So what do I mean? That is, this is a simple example for that. So suppose I have a variable a which has a value 10. So I want to do something for 10 iterations. So if you want to use a for loop, you can even use a for loop for that. You can just write for I in range 10, and then you can do whatever you want to. You can print I, you can perform any actions, and it would just perform it for 10 times. Even in while loop, the use of while loop is that it is useful when you don't know the length of an iterable, or you have certain conditions which needs to be fulfilled, and only then the looping should end. So in that cases, while loop is beneficial. So here I have a condition that till until a is greater than 0, you must do some actions. And here I am actually decreasing the value of a. This is very important because, and this is a shorthand notation. It actually means a is equals to a minus 1. So this is important because if I don't give this value, it would fall into infinite loop. It would keep on looping amongst itself. So this is the condition. So when I execute it, it would print, it would do the action, it would reduce the value of a, then it would check the condition, whether the condition is fulfilled or not. It would again go inside the while loop body, it would execute it again, then it would check the condition, and finally when the value was equal to 0, it checked the condition and it wasn't satisfied, so it went out of the loop, and here we have the result. So that's why here a decreased value is important, but we can work around that as well in conditions where we are not able to have uh, increments or decrements kind of things. So this is about looping. And yes, there's another kind of loop which is called as do while loop, but that is not present in Python. In do while loop, for others they might be knowing that it is similar to while, it's only that we have execution body written first and then the while condition is executed. So here you can see that the while condition was executed first and only then it went into the execution body. So suppose if I had given this as 0, it would have never executed it. But in do while loop, it will execute at least one and then move on to the execution and then move on to the condition. So this is how, but that is not supported in Python. So that is just for your understanding purpose. So any questions still here, then we can otherwise move on to the next topic. Okay, so we have something called as a break, pass, and continue. So what do all these three means is that break is usually used for getting out of a certain iteration. It will break the flow of the code and it would get out of that body. So for example, here I'm looping through a certain range and I have put out a condition that if the value goes above 5, then I need to break out of this. So what it does is that it is doing the action until this condition is met. When this condition was met, it broke out of the for loop and the execution flow of execution was broken up. That's why the loop ended at 4 itself, because when the value came out as 5, uh, the break keyword actually had broken the flow of that for loop. And so this is useful in cases of, mostly in cases of while loop, because in for loops you generally know the length of the iterable object. So it's a good practice when you're using while loops, because this is one condition when you're making use of increment or decrement. But if you don't have that, then you can just certainly give out a condition here that if the value is, suppose I have this, that if the value will be less than 5, then I don't want to continue with the looping. So in this case, it will break whenever value 5 is reached. So that's why this break statement comes in handy, but it is usually for practice, good coding practice, it is usually told that we should not use make use of break statements, because as you know that they break the flow of execution. So yeah, so I have a question: what is infinite loop, and how to know my while loop have control up to particular length program? In while loop, we usually have conditions specified here. So we must have uh, a basic dry run knowledge of what we are trying to implement. So this was just a basic thing that I'm printing out the value present in A and decrementing it. But if the condition is not satisfied properly or we haven't coded it correctly, then we can fall into an infinite loop, or we can have a logical problem. So in while loops, we must have a knowledge of what the conditions are and how the flow is going to be. So if I execute this, then you can see that it has gone into an infinite loop. It's just printing, printing, printing 10 every time. So here I had
Silas,
to break
yeah,
this up.
we have a my different question. Just like in another programming language, we are using some end statement. Just like we are using a while looping. So another programming we are using an end statement. We want to complete our program. So in the Python, how to know the up to this particular statement will work on this particular looping. Just like this time we are working on writing while a is greater than 0. Next statement we are writing print, and next statement we are writing another a equal to a minus 1. So how to know the
Yes.
maybe this program will work? Yeah, this statement will depend only up to this particular looping.
Okay. So that, as I told you, will depend upon how your flow of your code is going to be. Because as I already told you that if I remove the decrement statement, it would go into a infinite loop. And if I keep this value somewhere here, or if I change the value of decrements, I can
No, no, I'm
have
asking
different
only.
values.
No, I'm ask. Sorry. I'm asking only for the control of length of program. This program. So while program have some length, maybe another program we are using an in the statement. So in between, just like another program in while and last statement is the in statement. In between of this statement, when I writing anything, so this program have a control of the while and end. So Python have any of the thing we can identify. So there have a control in between them.
Sorry, I actually couldn't understand your question.
Yeah,
So,
yeah, yeah. Suppose this time I am writing a while statement, and next time I am also writing a for loop statement. So how to identify the boundary of these two programs?
you're saying a listed loop you're making use of?
No, no, no. I'm not listed group. Suppose there is a while a is greater than 0 and
Yes.
a equal to a minus 2, and next
Yeah.
program we have to for loop. So there in the below we can write some for loop program.
Yeah.
So yes. So I think have a so these while loop have a control up to this statement, print statement, and when you're writing your for loop program, so maybe have a they have a starting a new control. So maybe yeah, just like so I'm asking that just like in SAS mainly we have to defining as just like a while statement. So while
Okay.
and for the ending of this particular program, we have to define one of the keyword in the keyword.
Okay. So,
So I don't know about the Python. So just like in the program, A is depend on the our while looping, and print is also depend on our while looping. So maybe next
yes.
time also next statement also writing another statement just like a b equal to b plus 4 and c equal to c plus 4 and b and c we can be used in the while statement. So I think all are depend on the this while statement.
Yes, I
Yes,
mean,
yes, Shashi,
uh,
I'm audible to all of you.
yeah.
Yeah, yeah,
So
yeah.
Okay,
whatever
so
variables.
I think Shashi is asking is that uh, in case if you know accidentally forget to write this decrement statement and this loop keeps on running, so is there any limit by default that we can set so that this loop automatically gets stopped by after a few steps?
Yeah, that actually is taken control by Python itself. So after it reaches some number of iterations, that tries to identify whether it is an infinite loop or not, and then it gives out that error to us.
Okay,
So in that sense, we have that possible as well.
okay,
But
so
for
Okay, okay.
I think Shashi, this is the case that you want to ask.
Yeah, okay, okay.
Okay, okay, Salish, you carry on, please.
okay, okay. So yeah, so infinite loops, we should always try to have a conditions check before executing. Otherwise, infinite loops can be very time delaying and problematic for us. So that's why we have this break, pass, and continue to some extent. But these statements are actually not uh, enforced to use because as I told you, that break actually breaks the flow of your code. So that if we go into detailing, that would go much in detailing in the terms of machine language. So I don't want to go into that detail. But for normal use, you can just understand that since it breaks the flow of code, then that is not actually suggested a lot to be used in programming languages. Similarly, we have a pass statement. So pass is basically used when we don't have anything to perform there. So for example, we have a conditional statement present inside this loop, and we have an if and an else. So we can write a pass in the inside the if we don't want to perform any action inside the if block, or we can write the same inside the else. And what it would do is it would execute this branch, but nothing would happen. So it's basically you since inside a block, Python does not allow empty blocks. So to avoid the errors of empty blocks, you can make use of pass. But this is also not much enforced into Python because if you have many passes, then that means you are making redundant blocks in your code which are not usable. So this can be changed if we change the logic or we make use of something else. So suppose we can do this, and then we can get rid of that pass. So here we got all our values printed and we got rid of the pass as well. But it's just handy to know about what the pass keyword actually does. Similarly, we have a continue keyword. What it does is that it returns to your flow, to the starting of your flow. So whenever this keyword is encountered in a looping, so a looping mechanism is like it would go inside the block, it would execute the first block. Here we have a if statement. So what it does is, suppose I'm having another action present here, which is my print statement. Yeah. So now it would execute this. It would go inside the if the condition is fulfilled, and then this continue is encountered. So it would not let the flow of execution to go beyond this. Rather, it would return back to this flow of execution of the for loop. So in case of for loop, it will return here, and in case of while loop, it will return to the condition back here. So I'll just show you what it actually does. See, so when the value was 0, we got hi printed and hello printed as well. The if condition did not got executed as the condition was not satisfied. Then we got hi and hello 1 also, hi and hello 2 also, hi and hello 3, hi and hello 4. When the number 5 was accessed as well, then it printed hi. It went inside the if condition, but then it went back to the for loop condition, for line. So because of this, the print hello could not be executed, and that's why we have only highs printed after the value 4. So this is also another keyword which comes sometimes in handy, but again, as I told you that we can get rid of pass if we change some coding logic. We can rid of breaking if we know what condition to be satisfied in while or for loops. And similarly, we can get rid of continues as well. And it's just that these three statements are your uh, used in breaking the flow of the code, or as in case of pass, it just increases another code block or another conditional branching statements. So that's why these are the three keywords. If you have any doubts regarding this, you can ask. Okay, so let's head on to the next topic then. So the next topic is functions. Okay, so you asked, please repeat, continue, and pass. Okay, so I'll write another example here. Yeah. So here I have an example of pass. So when I execute this block, you can see that nothing was actually done here. So what pass actually does it avoids writing. You can avoid writing empty code blocks using this. So the if condition was satisfied because of the value of a, but in case you did not want it to execute this code, I mean conditional branch, or you wanted to check for other branches but nothing to be done here, then you can make use of pass. Because if you remove this pass and have an empty block, then what you get is an error of an unexpected indent block. So that's why to avoid that error, pass keyword is used, and you can have your regular flow of execution of the code. And that's why, but as I told you that you can change your logic and you would never have to encounter your pass statement or write redundant blocks. So here you can change the logic and have no use of pass as well. Similarly, in for continue, I think I'll make use of a while loop. That would be better. Yeah. So here I have a continue block, and let me show you a break as well. Mm, Let's add a print. Yeah. So this would actually make you understand what the difference between continue and break is and what continue actually does. So here, as I told you, whenever continue is encountered, it would take back the flow to the starting of the loop, but it will not make any changes to the values. It's just that the value of a and this all were executed, but the flow, instead of going to print, I mean the line by line execution of code occurs. So instead of executing this block, continue just means that this is, for layman terms, you can understand that whenever continue will be encountered, it would mean that this is the end of the block for this loop. So now again start the next iteration. So that's why here the a value was reduced, the high was printed, and hello was printed. Then a value was reduced again to 6, again hello was printed, but then the a value was reduced to 4. So when the value was 4, the if condition was satisfied, and that's why continue got executed. So it made the flow of execution back towards the while statement. And then again, the value of a was reduced, then condition was satisfied, and continue happened. So that's why in the last 3 iterations, print statement for hello and the value of a could not occur. But in case of break, what it does, it breaks the flow of the loop itself. So it will bring you outside the body of the while loop. So where here, when value of a became less than 5, it just executed break, and break, what it did, it brought you outside the loop body, and nothing could be executed after that. It's only that if you have a statement outside the body, then that normal execution will go on. So it broke outside the body of the loop, and then this line started getting executed. So that's why an SF is printed here. So that is about your break and continue. So I guess I was able to make you understand better now. If any doubts, then you can let me know. Okay, so let's head on to functions now. So in Python, uh, we have functions written in the form with starting with a def keyword, which is used to define a function. Then we have a function name, and then we have parentheses. So inside the parentheses, we can give parameters. So we can give arguments here, and these are actually the values which will be passed to the function for processing it. And then we can do the processing whatever is defined inside the function. So what are the use of function is that you can reuse a certain code block every time, instead of writing it every time. So you just write a function, you define the functionality what is to be performed, and then you can make use of it by just calling the function. So what do you mean by calling the function is that you write the name of the function and pass the value according to the definition of the functions, and then you can have your processing done in it. So for instance, I'll just write a basic function first without any value. So suppose this is my function, and this last line which I wrote is actually called as calling the function. So whenever this line got executed, it went to the function, which is defined by this name, and then executed the contents of the function. So that's why the print statement here printed this new value in function is, and that's what I got the result as. Now, a function can return, you may or may not return value from a function. So that depends solely on the basis of what functionalities you want to implement using your function. So here my function is not returning any values. Since I have written only return, and you can see there is nothing which I am returning here. My function is not returning anything. So if I do a print, then you can see none is printed because my function is not returning anything. I can even remove this return statement and do the same. Then writing a normal return statement is the same as not writing anything as return. But if I write something, some value or anything, then that value would be returned by the function. And while calling the function, I can even assign a variable to hold that value. So here a got the value 2, which was returned by the function, and that's what I printed here. So you can also have multiple values returned by the function, and it will be returned as a tuple. So as you can see, the parentheses are used. That means that it's a tuple. So the type which it returned was of type tuple. So now let's move on to some basic functions. So this is one function which accepts one argument. So I have one variable called as value, holding a value 10. So when I call the first function basic fun one, I'm passing that value. So this value will be passed on to the val argument here. So val will hold that value, and then I can do the computation and have the result as I want. So here I am not returning any value, but in the second example you can see that I am returning the new value of val here. So this is one of the examples where I'm performing the same actions, but if I want the new updated value, I am updating it by returning the value back. So this type of call is actually called as call by value, because in the first instance, as you can see, when I had passed the value to the function, here the changes were made and the new computation was printed. As you can see, 20 was printed. As you can see, 20 was printed, but when I had printed the value variable which was present outside the function body, then only 10 was there. So this value was not changed, but only inside the function body the computation value was changed. But if I wanted to get the new value, I had to return it, and that's why it got saved here, and then I got the new value here. So this is your normal function which is called as call by value, because a copy of this value was sent here and not the you can say the address or the pointer to that address. That's why the original value did not get changed. But in cases like in list, you have a call by reference which we call. So here what we got is we had a list called as list1, and we passed the old list. Then we ran the function, called the function, passing the list, and then we finally printed the new list. So here, as you can see that I had passed the old list here, and inside the list, a new element was appended here, and then the function had ended. So I had printed the list before calling the function and the list after calling the function. So you can see the changes to the values were made here. So this is called as call by reference, because the reference to the list or the memory of that list object was passed here. And that's why the changes which were made directly to the original list or the original object. So now you don't have any object or variable which is holding the list consisting of these elements. This is the new object which you have. But if you don't want call by reference and you want to have a call by value, then what you need to do is you need to send a copy of that list. So by doing this, see, since you made use of slicing here, so this means a copy of the list would be sent and not the reference of that list itself. So that's why after executing or calling this function, the old list did not have any changes in the value. But if I print the changes which I was making inside the function, you can see that the changes were actually made here. But the scope of these changes were only inside this function and not outside the body of this function. So this is the difference between call by reference and call by value. If you have any questions, you can ask. Otherwise, we'll move on to the next topic. Okay. So yeah. So if you remember, while we were discussing about conditions and iterations, I had mentioned about switch case. So what that actually means is that I'll just do a quick search for those who actually don't have. Yeah. So this is what a switch case usually looks like. You have a variable C and you have that switch function. So according to the value of C, it can be anything out of these A, E, E, I, and accordingly you can execute whatever uh, functionality you want to pertaining to that value present in the variable. So you can either do that in Python using if-else, uh, long if-else, or that can be really heavily. I mean, that can be a lengthy process. So there's another way of doing it by making use of a dictionary. So here, this fun uh, are actually the references to the functions defined earlier. So 0 is holding the reference of function 1 is holding function 2, and similarly for 3 and 4. So when I call the 0th function, it actually means I'm calling the function 1. And that's why function 1 got executed here. Similarly, I can write anything. But yes, you need to pay attention that since it is holding references, you can even change the reference. So for example, here function 1 got called, but now if I'll try to call function 2, I would get an error because I have already changed the reference of function 2. I have changed fun2 to 10. So I cannot have it as a function now. It holds a value instead of a function body now. So this is something to keep in mind while you're trying to implement switch case using a dictionary, or you can go by the normal if-else statements or nested if-else. So now in functions, we have different kinds of arguments. The first argument is called as required argument. So whatever we defined in the function body is called as a required argument. Now what that means is that if I don't pass any value to the function, okay, yeah, if I don't pass any value to the function, it would give me an error saying missing one required positional argument value. So because it is matching the signature, or you can say the declaration of the function with the calling signature. So it found that one value is not getting passed in, and that's why it is giving me an error that you need to pass one required argument, positional argument, and that's why this function got executed here. So I have a question. All print statements, it is mentioned what fun one. Sorry, Sangeeta, I could not get what your question is. Can you write something in detail? If you're asking regarding the switch using dictionary, then this fun one means the reference of function one. So here I had specified this, right? So what it does is switch 0 will give me fun one, and then I have the parenthesis. So that means I'm just making a call to the function. Okay, if you're asking about these print statements, then I'm sorry about those. So this is what it is. So whatever reference you take, accordingly that function will get executed. Sorry for the redundant print statements, if this is what your doubt was. Okay. So heading on to the keyword arguments now. If you might have been cleared by the required argument now. Now what do you mean by keyword arguments is that if we have more number of arguments, we might not have a function which needs only one or two arguments. We might have many arguments. So in that case, we must remember the name of those arguments and we can pass the values accordingly. So even by order, value comes first and new comes afterwards. But since here I made use of the same keyword which was present during the definition of the function, so the order did not matter because it was easily able to map it by the definition of the function. So when I called the function, it was able to map the value of new to new and the value of variable to value. So yeah, instead of this, we can also have something like this, and I can just pass it. So okay, I'll pass a better value. Yeah. So this is very useful when you have many number of arguments and you don't want a function to be taking care of the order of the arguments. So this is why we make use of keyword arguments. Next, we have the default arguments. So suppose you have a function where you want to pass one value, but you don't want to have the second argument to be you can say a required argument. So what you do is you give it a default value. So here I have given a default value as 9 to new. So by that what I mean is even if second value is not specified while calling the function, it would take the default value which I gave it during defining the function, and the function would get executed instead of giving an error to me while I was trying to access it. So this default arguments actually solves that error problem here. And if we execute this, then you can see that I made use of the uh, normal single valued argument as well. I made use of the keyword argument here as well. And then I did a normal call as well. So all the three got executed without any errors popping up. And finally, we have the variable length arguments. So in certain cases, they might be that you have very huge number of parameters, or maybe you don't know the number of parameters which can be passed on to your function. So there might be cases when you want to pass one fixed value, but the other value can be single value, it can be a list of values, or it can be no value, it can be nothing. So in these cases, a variable length argument is very useful here. And a variable length parameter is always a tuple. So this is defined with an asterisk at the starting and the name of the variable length parameter which you want to keep, and then you can call the function accordingly. Yeah, for good coding practice, it is always told that the variable length argument should be as the last parameter or the last argument of the function, because if you keep it in the starting, then the fixed parameters or the default parameters might not be accessed. So in default, even then the default value would be taken for the parameter, but for the fixed or the keyword arguments, then that would give you an error. So for example, here I have, okay, first I'll complete this. So here I passed on 1. So 1 was received by the argument val1 and it printed the value. And when it tried to print the variable length parameter, it got nothing. It got an empty tuple because nothing was passed while calling the function. But when I called the function using more number of parameters, then the first value was taken as 1 and the next two values 2 and 3 were taken as a tuple. And then I made use of a simple for loop to access those values of the tuple. We can make use of any functionalities which we want to. So now let's head on to the problem which I was talking about. So suppose you have defined your variable length parameter in the starting and the fixed one after it. So now if you try to call this, you will get an error because you have one required parameter here which is not able to get a value because of a variable length parameter defined before it. So that's why this function call gave you an error. But if you call it like this, then you won't get any error because your val1 will be mapped because of your keyword arguments present, and your variable length parameter will not get any value. And you can make use of this by more number of values as well. But as I told you, for better coding practices, the variable length parameter should always be mentioned at the last of the function definition so that you don't have problems like these in the first example as I had mentioned. So apart from this, we have something called as lambda functions. So if you want to create anonymous functions, you don't want to name a function or you want to create single line functions, then in that case you can make use of lambdas. So it can take any number of arguments as you want. So for example, I have taken 2 arguments but it will return only a single value. So you can return here only the multiplication of those values, or you could return only the addition of it, or I think you can even return the list related to it. But so by returning only single value, I meant that only one object would be returned. So you can, this is a single line function. So here I had given it a name as lambda fun, but I can even have uh, a lambda uh, which is running without a name. For that, we can make use of these lambda functions, and yes, you can even pass default values here. So as you can see that the default keyword works here, and I mean the default argument works here, and you were able to make normal calls even when one of the parameter was missing. So this is all about lambda functions. If you have any doubts, you can ask me right now. Otherwise, we can end this session. Okay, fine. I hope you like this session. Since you have no doubts, then we can end this session. The topics for the next session, I'll mention it in the group, and because I'll have to prepare it myself as well. So, okay. Thank you, everyone.